Okay, so welcome to the Intro to Python class. This is me, Erik Gross. I'm your instructor tonight. I'm a senior level software developer, a U.S. Navy vet. I was a nuclear reactor operator and electronics technician in the Navy. I'm also the co-founder of the Tech Academy, the school that puts on these free classes. And I'm really happy to have you all here, and I hope you learn a lot. A couple basic guidelines for the class. We have an assistant in the chat, Gracie. You'll see her. She's there to monitor the chat, answer questions. Super helpful. And please be nice. It doesn't happen very often at all, but every once in a while we have to remove someone. I don't think we'll have a problem. Y'all seem pretty awesome. Ginny says, "Go Navy, beat Army." Yeah, love hearing that. That's great. Okay, good. Oh wow, you went to the Navy Academy. Excellent. Okay. Couple things about the class. It will be challenging. You might run into challenges. That's part of the learning process. To work through those challenges, please use chat as necessary. I try to watch it the whole time we're teaching. And we do make this an intro class. We make it as easy to get through as possible, but you're going to be learning new things, right? Now, one big note on that, when we get to the part of the class where we're actually writing code, where you're creating computer programs, be sure to type the code exactly as written. This is because things like a misspelled word or a missing symbol or even something that's capitalized that shouldn't be capitalized can result in errors in your code. So I go slow, I try to, and just try to type exactly what I type as we get to the coding. Also on that, please make sure you're in a distraction-free environment. You can really focus on the class so I don't lose you. I really like people to get a lot out of these classes. So make sure you're not, have a bunch of, screaming kids around you or barking dogs or anything like that. If you fall behind, it's okay. Just listen and learn, right? Even if you fall behind on writing the code, you can still learn a lot by watching me code and listening to all the teaching moments as we go along. Every once in a while, we have people ask, is this being recorded? It absolutely is being recorded. And the video of it will be up on YouTube later today or tomorrow. We'll give you links to all of that and a lot more towards the end of the class. You'll also get the full code for the game that we're going to use as a teaching example. And you'll be able to play the game. You can have the code and mess around with it, tweak it as you want. And there we go. That's how the class is run. I think you're all pretty comfortable using chat. If you... Felipe asks about where we're going to write our code. It's an online code editor. We'll get to that later on. If you haven't dropped into chat and let us know where you're joining us from, do that right now. Drop into chat and let us know where you're joining us from. The YouTube channel you can find under the Tech Academy. We'll give you links to all of that towards the end. North Carolina, Manchester, UK. That's fantastic. Excellent. Connecticut, Toronto, Arkansas, more folks from California, Denver. Fantastic. All right, we have a truly international contingent today. All right, so here's the basic agenda. We'll have a short explanation of the Tech Academy, the school that puts these classes on. Then we're going to write code. I try to pay attention to the chat while we're writing the code and answer some questions as we go along. But we'll have a brief Q&A session after writing code for me to catch any questions that I haven't answered. Then we'll go over some information about our boot camps. We help people break into technology, and so we're going to talk about how we do that. And there's a free gift for you at the end, so please stick around. I think you'll like this gift. It's actually really, really, really cool. So just a quick introduction to the Tech Academy. We provide coding boot camps. If you're not familiar, boot camps are really intensive technology certification programs. They're designed to prepare people for entry-level positions in tech. They'll last typically anywhere from 3 to 6 months. They focus on practical, modern skills. It's an alternative to the college or university route to break into tech. That's what boot camps are. At the Tech Academy, we've been offering really thorough, budget-friendly, flexible, trusted coding boot camps for well over a decade. We just had our 11th anniversary a little while ago. Our certification programs, our boot camps, are cost-effective. They're self-paced. They're fully online. And they're tailored for beginners, people that have no prior technical or coding knowledge, which we'll talk about a bit later on. They cover really in-demand skills. They're endorsed by stellar online reviews, and they're really flexible. They're designed to fit around your personal schedule, and we prepare you for a tech career with a really well-rounded toolkit. We want you to have a long, successful career. Nationwide in America, the average price of boot camps is around $13,500. Ours are well under the national average. We even have boot camps that start as low as $59.80. And I'd like to wrap this part up by just talking about our mission statement. Why are we here at the Tech Academy? Our mission is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. That's our mission. Our product is you working in tech. All right, let's go and get started. We'll cover a couple of basic definitions first. Some of these you may be familiar with, some of you might not. First is just the concept of a program. This is just a set of instructions that you can enter into a computer to make the computer perform specific tasks. Instead of using a program like Microsoft Word or a video game or whatever, you get to make the program. You're in control, which is kind of cool, okay? You write these programs in a programming language. It's just a collection of, words and symbols and phrases that let you communicate with the computer and tell it what to do. Programming languages are how we create these programs. And then we'll cover the word coding. Coding is just the action of entering those instructions into the computer, setting it all up so that when you say go, the program takes what you wrote and does what you tell it to, okay? Code is the actual instructions that you're entering in. And we better cover Python because that's the language we're going to use tonight, okay? Python is a super popular programming language, been around for about 35, 36 years. And it's really popular for a few reasons. One, it's really easy to read it and just figure out, in most cases, what the program is doing. Two, it's very versatile. You can use Python to create all sorts of computer programs, anywhere from video games or full-blown, productivity applications or websites. Python's very, very versatile. So we like to teach it, and I like knowing it. Now, let me stop here for a second. We're going to go over a fair bit of material today. The slide we're about to go over is actually the most important data you will learn tonight, before you even write code. And we found that understanding these fundamentals helps you to learn how to code better, which is really cool. So we're going to talk about the 5 basic elements of any computer program. Doesn't matter what the program is, doesn't matter what programming language you use, any computer program will use these 5 things, and only these 5 things. It starts with an entrance point, or the first instruction of a program. And this is just what it sounds like. When the program starts, there has to be a first instruction, but something really important happens when you start a computer program. And here's what it is. Your program is going to make use of a lot of data. It's going to take in data, maybe from a user, maybe from another computer, and it's going to do something with that data, and then it's going to probably send that data on to a display, to a printer, to another computer. So the point is you're going to work with a lot of data, okay? Aiden asks, I've often heard Python being called a toy language. Does that mean it's less useful? Unfortunately, like any industry, people have opinions, okay? I can say, having programmed computers for about 45 years, that calling Python a toy language is actually one of the most foolish opinions I think anyone could ever utter. Python is an incredibly valuable, very powerful, very consistent, good language. It is absolutely useful, and I disagree strongly with anybody that characterizes it as a toy language or somehow less important. It's a phenomenal language to learn, and it's super in demand. So if you know how to program in Python, it really helps your job prospects. All right, I hope that helped, Aiden. So back to this concept of a first instruction. When you start your program, the computer that you're running it on does something really important regarding data. In your computer are little devices where data can be stored. They're called memory devices. You might have heard the term RAM. This is where you store data inside a computer, okay? When you start your computer program, when that first instruction begins, the computer does something really important. It reserves a big chunk of that available memory just for your program. No other program is allowed to access that area where data is being stored, so it protects the data that your program is going to use from being overwritten or changed outside of your control, outside of your program's control. And so that's a reason that this first instruction is important. but it's kind of important to the computer. There's a reason the first instruction is important to you as a programmer. And here's what that's all about. When you become part of a programming team and get assigned to be responsible for a program or more than one program, very often one of the first things you're going to want to do is to seek to understand how does that program work, to look at the code and see what the code is doing in the program. And one of the best places to start is with the first instruction. I think you probably see that if you start halfway through the program trying to understand what's going on, it can be kind of confusing. And so if you can, when you get a new program you're responsible for, find that very first instruction and just start reading through from there, it makes it very easy to understand what the program's all about, what it's doing. There's various ways to find the first instruction, but knowing that it's there and knowing it's super important can help you a lot as a programmer. So that's the entrance point. The next fundamental element of any computer program is what we call variables. Variables are just pieces of data that your program is going to use, and here's the important part. They're pieces of data that can change while the program is running. Think about a video game and you have a score in the video game. That's a piece of data, and that data will hopefully change if you play the game. If it doesn't, you're probably not doing very well at the game. But the point is, your program needs a way to keep track of that, and it uses a concept called variables. And you'll use those tonight when we write code. The next fundamental element of any computer program is what we call control or branching. This is extremely valuable. This is how you get a computer program to make a decision. And you'll find that one of the reasons that human beings make computers is to help automate things that they could do manually. And when we're working, we have to make a lot of decisions. And so your program needs a construct, a way that you can tell it, here's a piece of data that you can make a decision about. That's the control part. And here are 2 or more possible courses of action that you can take depending on the decision that the program makes. Those are the branches. And so this control and branching is a vital part of a computer program. A program is of very limited use to us as humans if we can't program it to make decisions. And you do that with control and branching. And you'll do some of that tonight. The next of these 5 fundamental elements of any computer program is what's called a subprogram. And I love this concept. You see what it says on the screen. It says a program within a program. Here's what we really mean by that. Let's say you have a massive program, say 5 or 10,000 lines of code long. Big program, right? What you'll find as you're creating that program is that very often there's a set of actions you need to take repeatedly, over and over again, at various points in the program. You're executing, say, the exact same 5 instructions many different times within your program. Well, it can be very helpful to package up that set of instructions that you're going to use over and over again into a little container called a subprogram and give that subprogram a name. And that way, every time in your program that you need those series of instructions to happen, you don't have to type them all out. You can just say, hey, now go do that subprogram, and when you're done, come back and pick up where you left off. And we're going to build subprograms tonight. They're very, very powerful. The last of these 5 fundamental elements of any program is an exit point. Your program needs to have a final instruction, a way that the computer that the program is running on can know, hey, this program is done. There's a lot of things that happen when a program is done executing, when it's closed or turned off, whatever the terminology you want to use is. But one of the most important relates to the entrance point. If you recall, I said that when we start a program, the computer that it's on is going to reserve some of those memory locations. Well, when the program exits, when it's over, the computer releases those memory locations and makes them available for other programs. It doesn't lock them up. And so you need an exit point. You need a way to tell the computer, this program's done, it's over. So those are the 5 fundamental elements. I want to stress a couple of things about this. 1, these are the only things you will ever find in any computer program. Even huge, massive programs, they're only made up of combinations of these 5 things. And in fact, you've got 1 entrance point and 1 exit point. So really, it's the middle three you need to learn really, really well. And when you're learning a new computer programming language, one of the smartest things you can do is go, how do I work with variables in this language? How do I do control and branching in this language? How do I do subprograms in this language? And if you get through that study, you'll know the fundamentals of that language really well. So this is a fact that these are the 5 elements of a computer program. Knowing this can help you study any computer programming language. All right, so that's that slide. Let's start writing some code. We're going to do this in a code editor, a place where you can type in your instructions and then you can run them. We're going to do that in a nice online tool that we're dropping a link into chat. If you can get that, Gracie, that'd be great. Okay. And when you get that link, go ahead and click on it and you will see a code editor. There's the link. Everybody click on that. And you're going to see a code editor. It's going to look kind of like this thing on the right here. You're going to have a screen where there's a bunch of code. Ignore the code for now. There's a bunch of code instructions. And on the right is an empty panel where output can go. So I'm going to give everybody a moment to click on that and open it up. I'm going to take a sip of water. All right. Now, excellent. Thanks, Felipe. I would like you to set it up so that you can see my screen on one side of your monitor and the code editor you just opened on the other side of your monitor. Now, if you've got 2 monitors, you're golden. Put me on one and the code editor on another. But if you've only got one monitor, then set them up side by side, okay? To do that, you may need to resize the Zoom meeting, which is where I am, okay? And if it won't resize easily, you can sometimes click on the Zoom meeting word and this restore button, and it'll help you resize and move around the window with Zoom on it. Do that and put it on the left-hand side. And then on the browser, which is where your code editor is, you can resize it with this little symbol right here and set it up on the right-hand side. I'll give everybody a moment to do that while I get the code editor. All right, so let's go and get started. First thing, we don't want any of this code. This is Python code. Well, the green part are called comments. It's not actually code. It's just there to help programmers understand what the program's going to do. But we're going to erase all of this, and we're going to start from scratch. So the first thing we're going to do is we're going to do a simple instruction. But even in this simple instruction, there's a lot of cool things to learn. We're going to make output appear on the right-hand side. We're going to print something to the screen, okay? The built-in Python instruction for that is print, P-R-I-N-T. So type that out, and then give yourself an open and close parentheses. You'll notice that all you have to do is type the open parentheses, and this code editor, which is super friendly, makes the closed parentheses for you. Makes your job faster, okay? And then inside those closed parentheses, give me a double quote. The code editor will make a second one for you. It's supposed to do that, okay? And then inside there, we're going to type hello world with an exclamation point. Now, when we're done with all that, go to this triangle symbol at the top right here, which is, it'll run your program, and you'll see the output on the right-hand side. All right, now, simple kind of cool thing. We printed something to the screen, but we have a program. Obviously, the program doesn't do a lot, but even on this line of code, there's a couple of really cool learning things. So let me show you what this is all about, okay? First of all, print is an instruction that tells the computer to do something. Pretty straightforward. These parentheses are used to provide information to the print instruction. In other words, the print instruction can't do anything by itself. It needs to be given information in order to do its job. And this pattern is used in a lot in Python. In fact, a lot of different languages. But it's used in Python over and over again, where you have an instruction that's going to do some work. but that instruction needs to be given some information before it can do the work. The terminology we use in programming is we're going to pass information into the instruction. So what we're passing in is this text, hello world. So the parentheses are to contain text or something that has a text value, which we're going to look at in a moment. But the whole point is you have to give information to the print instruction or it can't do its job. If we just did print like this, nothing happens. You need to be given information, okay? So I'm now going to do something that's going to seem very slow and laborious. Please bear with me. It's a super important learning moment, okay? I'm going to show you what the computer actually does when it reads this line of code and runs it. And I'm going to show you one step at a time, because computers do one thing at a time and they do it in an exact order. And computers can only do what they've been programmed to do ahead of time. They can't just figure out on their own what they're supposed to do. They cannot act without it receiving explicit instructions on what to do. It's just a machine. It doesn't think. So, how does the computer actually execute or run this line of code? This is what it actually does. The first thing it does is it reads the very first character, the P. And it checks basically for two things. One, is this content that I'm looking at, the letter P in this instance, is this a built-in instruction in Python? And two, if it isn't, is this code that I'm looking at, is it a variable in the program? Now, I know we haven't even made any variables, but variables have names. We don't have any. So the computer will look at this letter P and go, huh, it's not a built-in instruction. There's no instruction called P in Python, and it's not a variable. We don't have any variables in our program yet. All right, let me go to the next. And then it looks at both the P and the R together. Well, that's not an instruction in Python, and it's not a variable. Okay, I'm not going to do anything yet. So on and so forth. They look at the PRI, not an instruction, not a variable. You look at the PRIN, not an instruction, not a variable. You look at the PRINT. Oh, the computer has been programmed ahead of time to know that's an instruction in Python. And it knows exactly what it's supposed to see next. It knows that it's supposed to see an open parentheses and then sometime later a closed parentheses, and that the information it needs will be in between them. So, having figured out the computer knows it's dealing with a Python instruction, it looks up inside its own internal instructions what to do and says, okay, let me find the open parentheses. So it looks at the next character. Oh, I found the open parentheses. And then it'll go through one character at a time, looking until it finds, oh, a closed parentheses. And it will then go back and it'll say, oh, inside here should be text, and text is inside of double quotes. So it'll grab all of this content and go, I now have the information needed for this print instruction that I know I'm executing to actually work. And only then will the computer actually perform the work. The computer literally reads through this instruction one character at a time until it knows what it's dealing with. And then it looks for patterns. The pattern of an open parentheses followed by a closed parentheses. And then another pattern, a double quote, and then another matching double quote. And it grabs everything in between and says, ah, that's the content I need. And then it does the work. So I illustrate this, not to be boring. I hope it didn't bore you, but to illustrate, I showed you this to illustrate how methodical, boring and stupid computers are. And I don't say that in a derogatory way. I just want to stress to you the computers at their core are very simple machines. It's a very simple set of instructions to tell a computer, hey, look at each character until you identify an instruction that you can execute, and then execute that instruction by looking for the data in the exact right pattern. And once you have all that, go ahead and do the work. That's how computers work. And that's how you'll make programs, one step at a time, based on exact patterns, the rules of the language, and that way the computer can actually read it and figure out what to do. All right, so with all that said, let's move on. We're going to move on to variables. Remember I said variables are a way to keep track of data that can change. So the whole context here, by the way, is a tic-tac-toe game. And we're going to look at the full game in a moment here, okay? But in a tic-tac-toe game, well, I'm going to show you actually the game in case there's people that aren't familiar with tic-tac-toe. Don't worry about all this code. You're going to get a copy of this later. Don't change your code. Leave your code the way it is. I'm just going to run this program and show you. Oh, sorry, it's tic-tac-toe. So we're playing tic-tac-toe, and I've got A, B, C, and 1, 2, 3. I have a little grid, and I'm going to put my X right in the middle of B2. Okay, so I put my X right there. They put their O right here. I'm going to put my, let's see, I'm going to go A3. Block me, will ya? Well, I'm smart. I'm going to go B3. And now you can't win because I have C3 and I won. So that's the game. All right, so again, we're not going to program this whole game. We'd be here for a few hours and you'd all want to go to sleep. Okay, but I'm going to use this idea here in terms of making a variable. Let's go back here. All right, and go back to my program. I want to keep track of whether or not there are 3 in a row. So I'm going to make a variable that keeps track of how many X's in a row are there. I'm going to give this a variable name that I think, let's see. Hold on just a second. I'm looking for a good idea here. Yeah. I like a variable called, and by the way, you can skip a line. It's not going to affect your program at all. It makes it easier to read. I'm going to go X in a row. That's the name of my variable. And by the way, if you're looking for that underscore key or symbol, it's in the top row just to the right of the 0. And you have to do a shift, like shift dash gives you that underscore. That's my variable, okay? Variable names cannot have spaces in them. All right, so I've given a name to my variable. I'm going to go equals, and I'm going to say 2. Now I'm going to do a semicolon. That semicolon tells Python that's the end of the instruction. Now let me explain exactly what's occurring on this line, okay? First of all, when I give this instruction, this word is an instruction to Python. It's an instruction that says, create a variable with this name. Just putting the name of the variable you want tells Python to make the variable for you. Now, here's precisely what's occurring down inside the computer. You remember how I said that the RAM, or like the memory devices inside your computer, they are used to keep track of data, right? Well, you can think of that memory as millions of little individual buckets. And you can put information into each bucket. Each bucket needs to have a unique name on the outside so that you can find your bucket out of all of the millions of buckets of memory. We're giving the name X in a row to our bucket. The actual technical word we use is we are declaring a variable. Now, this part's important. So far, we have not yet put any information inside the bucket. We've just given it a name. It's this instruction right here, the equal, that tells the computer to put some information in the bucket or to put it in the memory location. It's called an assignment operator. We're going to assign a value to the variable. The value we assign is a 2. So again, you can think of it as we have dropped the number 2 into our bucket that's called x in a row. The actual terminology is we declared the variable x in a row and we assigned it the value 2. What does this mean in real world terms? I've only got 2 x's in a row, which means I have not yet won the game. But let's use this variable. Let's print to the screen. So do print, quote, number of x's in a row, colon, do a space, and then go right after the double quote. Make sure your cursor is where mine is. I'll pause for a moment for people to get caught up. And then do space plus, and then type your variable. Type it exactly the way I did it. X underscore in underscore a underscore row. Make sure you type it exactly the way I did. And then put a semicolon at the end of the line. And run it. And we got an error. Now, I did this on purpose. I want to talk to you about why we got an error, because it opens up another really important thing about learning. First of all, let's see. So line 4 is this instruction, and it says type error. Can only concatenate. Now, let's define that word concatenate. Concatenate means to take 2 pieces of text and connect them together. That's what concatenate means. Like if I took the first name Erik and the last name Gross and I concatenated them, I would have Erik Gross. It takes 2 pieces of, and this is important, 2 pieces of text information and connects them. Now, what's the problem here? It has to do with this word right here. STR stands for string. The next important concept to understand about computers is they deal with lots of data, but not all data is the same as every other data. You have number data, you have date data, and you have text data. Text meaning like numbers and letters. In computers, we call text data strings. Technically, that's because it's a string or a collection of individual characters, but we call it strings. So what's the problem here? The problem is that I've used this plus symbol, which means concatenate. It doesn't mean to do math. This symbol right here means to take one string, in this case, the phrase number of x's in a row, and another string, my variable, and put the 2 strings together. The problem is that the variable x in a row, the value stored in it, is not a string. It's not text information. It is number information. Specifically, it is integer information. It is a whole number. It's not like 2.5. It's just 2. It's an integer. So when I use this instruction, plus, which means to concatenate, I'm telling the computer, I'm going to give you 2 pieces of text information. I'm going to give you 2 strings. I want you to connect them together. And the computer is saying, hey, buddy, I would be happy to concatenate these 2 strings, but one of them isn't a string. It's an integer. So I can't do what you're telling me to. Now, another real big concept that I'm reinforcing here is computers can't just quote unquote figure out what you meant. I know what I meant. I know that inside this variable x in a row is the value 2, and I just want to print that number 2 to the screen. The computer can't figure it out for you. You need to be precise. You have told the computer with this symbol right here, I'm going to give you 2 strings, and then you didn't, in fact, give it 2 strings. So it says, break, sorry, stop, error. So what do we need to do? We need to take the value in here, in this variable, which is a number value, and we need to turn it into a string. We need to turn it into the character 2, not a number 2, not a number that can be used in math, but just the symbol 2. And you do that by converting it to a string. Now, here's another important lesson. I don't memorize the syntax or rules for any of the languages I know. I know a lot of different computer programming languages. You will too if you stay in technology for a while. I don't memorize the exact rules for how they work. So what I'm going to do is I'm just going to say on Google, how to convert integer to string in Python. And it says the most common and straightforward method is using the built-in str function. And look, it says here's a variable called number. It's got a value of 1, 2, 3. Here's another variable called string number. And it says take the variable number and with this instruction, turn it into a string. Huh, I like that. So go back here. And right before X in a row, this part's important. Watch exactly what I type and do the exact same thing. Type str parentheses, but then you have to go to the end of the variable and do another matching parentheses. I'm going to wait for everybody to get caught up, and I want to explain. str is a built-in instruction in Python. And it is one of these instructions that needs to be given information in order to do its job. Specifically, this instruction, str, is an instruction that can receive a number and convert it to a string. Well, you need to give it the number. And so what we're actually giving it is, we're giving it our variable, and that variable has a number inside it. And so when we run this function, string, so we run this instruction, string, it will take the number 2 and turn it into a string 2. Run your program, and now it works. All right. I'm going to watch chat for a second. Anybody have any questions about what we just went over before I move on? Awesome. This whole concept of data types is super important. Every programming language out there, whether it's Python or JavaScript or Java or C#, there's thousands of programming languages. They all have certain types of data they work with all the time. But they're generally the kinds of data that we're used to working with. In real life, we work with numbers all the time. We work with dates all the time. We work with character or text information all the time. And the programming languages are built to work with those kinds of data. But just like in the real world, you can only do certain things with certain kinds of data. You can't do math on the word Wednesday. You can't say, what is 5 plus Wednesday? First of all, everybody will look at you weird and walk away. But secondly, it just doesn't make sense. There are 2 different kinds of data. Math doesn't work with the word Wednesday. So, learning about the different types of data and how to use them in a given programming language is a super smart way to get started learning the language. And that's why I did this thing that produced an error on purpose. All right, so let's move on. Let's hit enter a couple of times there, just to have some room to read. Well, we now need to talk about control and branching. And we're going to use, remember, this is a way to have the computer make a decision. Let's say someone has just dropped an X on the board, and you had the computer program figure out how many X's in a row does that person have, and it counted them up, and it came up with 2. So Has the person who plays X won the game? No, they haven't. You've got to get 3 X's in a row. So we need to tell the computer how to make a decision of whether or not the player X has won the game. And if they have, then we can say something nice like, yay, you win. If they haven't, we can say something encouraging like, keep trying, but we need to make a decision. And so now we're going to do control and branching. You do that most often in Python with a built-in instruction called if. Now I'm going to build this partially and then fill in some of it afterwards, and I'll show you why. So type if, and then do your open and close parentheses, type a colon, not a semicolon, but a colon. And when you hit enter, you will notice that the cursor is 2 spaces over to the right. That's called indented, and there's a very specific reason why. What we are telling the computer to do is this. And again, we're not done writing this full control and branching. But what you're doing is, right inside this parentheses, you're going to put some decision that the computer can make as to whether or not something's true or false. And if the decision, again, we have not written this code yet, okay? But if the decision that the computer comes up with is, well, that's true, then the computer will only do the instructions directly below it that are indented. It will only do those things. And this is how we can have two or more possible courses of action. Remember, I said control and branching is all about having a computer make a decision and then providing it with 2 or more possible courses of action or branches that it can do depending on the decision. So, again, we have not filled in all of this, but let's go ahead and fill it in. Put your cursor right inside those parentheses, and we're going to give it a condition. We're going to give the computer something that it can determine whether it's true or false. And what I want to do is figure out whether or not the variable x in a row is 3. Because if it is, the person has won the game. So I'm going to type my variable. You do this too, x in a row. I'm going to hit space, and then I'm going to use a new symbol we haven't used before. 2 equal signs, and then a space, and the number 3. Let you all get caught up. Let me explain what this funky symbol right here is. This is not a math symbol. It's not even an assignment operator like we had here, where we make a variable and we assign it a value. This is its own unique thing. It's called a comparison operator. An operator tells the computers to do something. This is an operator, but it's an assignment operator. It tells the computer to assign a value to a variable. This is a comparison operator. And what it does precisely, it says, hey, compare the data on one side of me to the data on the right side and determine whether or not they equal each other. True or false? Do these 2 pieces of data equal each other? And if they do equal each other, then do every instruction below this that is indented. So, what do we want to do if the variable value does in fact equal 3? Well, we want to print you win. And give me a semicolon. Now this part's important. What if it's false? What do we do then? Hit enter, and this is critical. You have to back up right to the beginning of the line. Because we are no longer listing out what to do if this condition is true. only the indented instructions get performed if this is true. Well, we've stepped out of that. Our next instruction is a built-in instruction to provide the second possible course of action. Type else. That's a built-in Python instruction. And do a colon. And notice when you hit enter that the editor automatically indents for you just because it's a nice friendly editor. And what we're going to do here is we're going to provide the instructions on what to do if this condition is false. We're going to print, well, you should probably spell it correctly, print, sorry, keep trying. And then a semicolon at the end. Now, just to make it easier to talk about this, hit enter and then backspace. This structure right here is one of the more important things to learn in Python. It is the control and branching concept that we talked about earlier. You are controlling which of two or more possible courses of action the computer will take. Specifically, we're saying, here's a course of action, and here's a totally different course of action. And we're going to use this control statement to determine when to use this course of action, and this other control statement to figure out when to use this course of action. The colons at the end of this line are what tells Python, hey, this is a control instruction. Look for indented instructions below this and only do the indented instructions. And when you're done, check this one. And if it's true, then only do these instructions that are indented. So let's run this. And it says, sorry, keep trying. Well, first it says our hello world. Then we used our variable. So it says number of X's in a row. And then it says, sorry, keep trying. Well, why don't we go up here and change this to 3? And then run it. And now it says you win. Kind of cool, huh? Well, check this out. Remember how I said that variables, let's change it back to 2, okay? Change that back to 2, run it, make sure that it still says, sorry, keep trying. Remember I said variables keep track of data that can change. Now let's say our player drops another X, and they do in fact have 3 in a row. So let's take our variable, X underscore in underscore A underscore row, and let's give it a new value. So here's my question. Don't run the code. I want your guesses in chat. What is the final message going to be over here on the right? Don't run the code. Just guess. What do you think is going to come out as the last instruction? It's about 50-50. Some people think it's going to say you win. Some people it's going to say, sorry, keep trying. The correct answer is, sorry, keep trying. Run it, and you'll see. Now, for those of you who thought that it might say you win, let's talk about exactly why. This is a super important concept. Every time we run the program again, it's like it's never run before. So when we click on this run button, the computer doesn't remember anything from what happened before. Now, it does the instructions one at a time in order. So on this line, we've made our variable X in a row have a value of 2. So we are checking Does x in a row equal 3? And it certainly doesn't. It equals 2. Because it doesn't get changed to 3 after we run this code. So when we change it afterwards, the program doesn't care. It's like, okay, all right, there's a new value of 3. What next? So that's why it says, sorry, keep trying. Because at the time we checked the condition, the value of the variable x in a row was still 2. We only changed it to 3 afterwards. So hopefully that'll help you read through a program and see what it's doing. All right, so now let's talk about a problem we have. We're going to have players dropping, X's or O's on this on the game board over and over and over again while they play the game, right? I don't want to have to do this check every single time the X player drops an X on the board. In other words, I don't want to have to write this code 5, 6, 7, 8 times. I want to write it once. I have a super awesome opportunity to create this sub-program that we were talking about. So what we're going to do is take the logic that we created here. The logic we created was check to see whether or not the player has 3 in a row. And if they do, tell them they won. If they don't, tell them to keep trying. That's the logic. And we're going to take that logic and build it into a tiny little box called a subprogram with a name. And then every time the player drops an X, we can check whether or not they have 3 in a row. And all we have to do is call on that box to be executed. Let's build it. You do it by creating what's called a function. And in Python, this concept of a subprogram is called a function. There's different words for it in lots of different languages, like function, subroutine, subprogram, method. In Python, they're called functions. And you define a function by first giving it a name. So we're going to go def, that's a built-in instruction in Python that says, I'm about to define a function. Hit a space, and we need a name for this set of instructions we're about to create. I'm going to call it check win. That's what it's going to do. We're going to check whether or not someone won. All right, so next concept. Do an open close parentheses. Go to the end here. We're going to fill some stuff in. Go to the end and hit a colon. And notice when you hit enter, we indent. Because what we're about to write down is the instructions that will be performed. And this part's super important. Pay attention. We're about to write down instructions that will only be performed when we ask for this check win function to be performed. And they are indented by 2. But we're not ready to write the instructions yet. We need to do one more thing. Remember how I said that lots of instructions need to be given information in order to do their job? The print instruction needs to be given, well, what text do you want me to print, right? The if instruction needs to be given a condition it can look at and evaluate whether or not it's true or false. Our function is no different. It needs to be given some information before it can do its job. And we are going to hold that information in a variable. So we need a name for the variable that represents the information it's going to receive. I'm going to call it how many. How many in a row? That's a perfectly fine name. We can call it whatever we want. We can call it Erik. We can call it Foobar. I'm going to call it how many. And now go down, and we are about to detail the instructions. And this, again, super important. These are the instructions that are only going to happen if later on in our program we ask for the check win function to be done. What do we want to do? Well, we want to take this variable right here that represents how many uh, pieces the player has in a row. It's going to be 0, 1, 2, or 3, right? We want to take this and figure out whether or not the person won. So we can go if, and here's our variable, how many, and then equals, remember it's 2 because we're doing a comparison, 3, colon, and when we hit enter, it'll indent again because this is the branch that's only going to be happening if how many equals 3. And we're going to print, you win. Awesome job. Give me a semicolon. And now we need to figure out what to do if it doesn't equal 3, if how many doesn't equal 3. So backspace once. So we're on the same level as the if. You see that? We're on the same level as the if. And now we'll do our else. When you hit enter after the colon, right? Now this is the instruction to be performed if how many doesn't equal 3. Well, we're going to print, sorry, sucker. Keep playing. There we go. And a semicolon at the end. Now, don't run the program yet. When we run it, what is the final word or phrase going to be over on the right? Put your guesses in chat. When we run this program, what's it going to say at the end of all this? What's the last thing that's going to be printed on the screen? Give me your guesses. That's correct, Muhammad. Good job. Give me the full thing. Sorry, keep trying. Okay. Charnel, you are amazing. Okay. Some of you guessed that it will say, sorry, sucker, keep playing. Some guessed, you win, awesome job. And some of you got it right. The correct answer is, sorry, keep trying. Run it. And it's sorry, keep trying. Let's talk about why. Remember, the computer only does things one step at a time in order. So first we have a variable called x in a row. We set it with a value of 2. And then we check, does x in a row equal 3? It doesn't. It equals 2. So we print, sorry, keep trying. We then change the value of x in a row to 3. And then we have a function called check win. Now, check win is a function. And remember I said functions are instructions that will be performed only if you ask for them to be performed later in the program. And we've never asked for check win to be performed. Besides, the variable that it receives is called how many, not x in a row. So this function, we never even asked for it to be performed. Any questions about that? Drop them in chat if you have questions. Now, how do you have one of these functions be performed? How do you ask for it to be performed? Go to the end here and hit enter. Make sure you backspace twice so you're back at the beginning of the line. Hit enter just for readability. You don't need that extra line, but it's going to make it easier to read what we're doing, okay? And the way you call for a function to be performed is you just type out its name. Check underscore win. And let's say that the player only has 2 in a row. So we're going to give it the number 2. Run your code. And now it says, sorry, sucker, keep playing. Because we called on the check win function to be performed, and we gave it the value 2, which means the function takes that value 2 and assigns it to this variable it uses called how many. So how many is now equal to 2. So we check, is how many equal to 3? It's not. So we do this. But now go to the very end again and say that the person dropped another piece on the board and they got 3 in a row. So do check underscore win, and we'll pass in 3 and a semicolon. And now they win. Notice that we were able to perform the same logic that we performed right here. We have 4 lines of code right here. We did the same logical procedure with 1 line of code right here because of the function. That's that subprogram concept. Makes it super helpful. The other thing is that if we want to change something about how the function works, we can make a change in one place in the definition of the function, and that change is reflected everywhere the function is used. So let's say sorry sucker is really offensive. We go in here and we erase the word sucker. Now, every time we use the check win function, it uses this new updated instruction. Notice it says sorry, keep playing, instead of sorry sucker, keep playing. It makes it very easy to maintain your program. It makes it much less likely you'll make an error. If you had to type in this exact set of instructions over and over again right here, it'd be easy to make an error. So that's some of the value of a subprogram. Again, we call them functions in Python. So let's review some of the things we've talked about. We know that there's a first instruction. It's literally listed as the first thing here, okay? We know we can set variables that'll keep track of data that'll change. Here, the variable had a value of 2. Then we change the value of it to 3. And we know we can create we can do control and branching things where we give it a condition to check. And based on the condition, it will do one thing or it'll do another thing. And there's ways to set it up so you have multiple options, 2, 3, 4, 5 different options. The important point is you have to give the computer explicit instructions on what to decide on and what to do in every possible instance of the decision. If you don't tell the computer what to do, it'll either break or not do anything. It can't figure it out for you. You have to think ahead of time of all the possibilities and account for each one. So, for example, we might want to do one thing if they only had 1 in a row, another thing if they had 2 in a row, and another thing if they had 3 in a row. Maybe if they only have 1 in a row, we'll be like, nice try, but you need a little more work. If they had 2 in a row, we could say, hey, you're getting really close. If they have 3 in a row, we could say, hey, you win. But you have to define exactly what to do in each case inside your computer, inside your program. And then we looked at a subprogram. We're defining a set of instructions that can be performed over and over again on demand every time we ask for them to be performed. And all we have to do is print the name of our function, give it the information it needs, and it will do those instructions for us. So now we're going to look at the actual full program. Gracie, can you drop the link to the code in the program? Everybody take that code, copy all of it, and then go over here, erase everything, and paste in that code. And then run it. And then you can play a game. I'm going to go A1. And I'm going to go see B2. Sorry, I win again. C3. I win. And I'm not going to play again. So take a moment and just play the game. And then we're going to look at the code a little bit. Now, This program is all of about maybe 70 or 80 lines long, okay? But again, if we had tried to take the time to build this whole thing tonight, it would have been about a 2 or 3 hour class, and it would be very exhausting. The fact is, those fundamentals you just learned, the 5 elements of any computer program, that should serve you in really good stead as you attempt to learn any language or any program. You'll see those 5 elements in here. First of all, a special instruction I want to call to your attention is called import. There's a concept in most computer languages of libraries of code. This is pre-made instructions that you can bring into your program and make use of. You don't even have to write them yourself. They're already made for you. And these libraries of code are all centered around one or another sort of, field of operation. In this case, there's a library of code called random, which helps generate random numbers. There's also a library of code around time, which helps control like waiting certain amounts of time for things to happen. And so we don't want to have to write all that code. We're just going to bring in somebody else's code by using the import instruction. But then look, we're defining a function called print board. We're defining a function called check win, right? Another one called get computer move. Another one called get user input. These are all functions. There's another one called is board full. And here's get replay input. Does the person want to play again? Here's another function. This is the main function. It's called Tic-Tac-Toe. This is when you run this function, the game starts. And notice, after this, we call the function Tic-Tac-Toe. This is where the program actually starts doing work. All we've done before this is we made one function after another. And remember, the function doesn't get performed unless you ask for it to be performed later in the program. So we're just making function after function after function after function. And finally, after we've declared all these functions, we say, hey, please run this function. And in this function, tic-tac-toe, we call other functions. Look, here's what we call the get user input function. Here's what we call the print board function. Here's what we call the check win function. So you can call other functions from within your function. But I just want to stress, even though this code may or may not look kind of complicated, it's still only making use of the 5 basic elements of any program. Entrance point, variables, control and branching statements, subprograms, and exit point. That's it. All right. Let me go back here. And let's check the Q&A. All right, I'm going to look at the board here and see. Yeah, there'll be a YouTube link for the recording that we're going to share at the end of the class. Aka, hold on just a second. Pamela asks, does it check to see what the data type is once it's passed into the function and is used? That's a brilliant question. Let's see. Yes, so when we pass in how many, it knows what data type it is. It knows here it was given a 2. Watch what happens, by the way, if we passed in, instead of 2, the word hot dog. It doesn't know what to do with it. It doesn't, it just doesn't compute. It doesn't work, okay? So it's not going to say you win or sorry. It's just not going to do anything. All right. So yes, it does check to see which what data type it is. That's a good question. Let's see. Drop other questions in the chat if you would. Any questions you have. Can you explain the process of designing the game logic for tic-tac-toe? Yeah, I'm going to just a very brief tour of how I would think about this. The first thing I would want to do, let's see, is I would want to think about how to print the board. Okay. In other words, I would want to be able to print the rows, and then I would want to be able to make these little symbols right here for the columns. Like when we play this game, I would want to be able to just print A, then B, then C, and then the dashes, and this is called a pipe character right here. You can find it above your enter key. Okay. I would just get it to print that as the first thing. Okay. The next thing I would figure out is, how do I get input from a user? If I ask the user for their move, how do I get that user input right here? Okay. And I would be able to, I'd figure out the logic of, if they give me an A or a B or a C and a 1 or a 2 or a 3, where does that place their symbol? That's the next thing I would solve. The next thing I would figure out is, how do I get the computer to make a decision, to choose a random spot, which means I need to figure out it can only choose empty spots, and then out of those empty spots, choose one. Then I would figure out, how do I figure out whether someone won or not, which is right here. That's the logic I would use in trying to solve this game. Does that help? Oh, Ginny, that is so awesome. I want to give you a high five through the computer. Let me explain what her question was. Ginny says, so it seems like in Python, the beginning might always be at the end of the code file, since the functions and variables are set up before the main code is run. If I could give you a high five through the computer, I would, like I said. That's genius. Yes, that's exactly right. Remember how I said that there is, and I'll go back to the slide here because I know we had a couple people that arrived a little bit late. 5 fundamental elements of any computer program: the entrance point, variables, control and branching, subprograms, and exit. And I said, for the entrance point, some of the value to you of knowing where the program starts is that it helps you to read through a program and understand it. Yes, when we look at this program, technically the first instruction is we're going to import a library. I don't care. In terms of understanding the program, that's of limited value. What I really want to know is, where's the first point in this program that real work begins? And so, as Ginny said so well, all we're really doing is setting up a bunch of functions and variables, functions, variables, functions, functions, and finally, we ask for a function to be performed. That's the true entrance point to the program, because that's the first point you can see, what is this thing going to do? And again, Ginny, I love your question. Very rarely do we have people ask that, and it's really insightful. For all the different programming languages, it's not always the same place to look. But you can Google it. You could say, I'm learning to code in Python. How do I figure out where the first instructions in a program are actually occurring? And it'll tell you stuff like that. Brilliant. And Aiden asked questions about, how does it prevent you from putting an X on an X or an O, like for using an empty one? We don't have time to go through all the logic on that program. It is rather complex logic right here, which is the place it's the computer move, random empty spot. Okay. Yeah, it has to do with checking whether or not that grid is empty, but we don't have time to go through all that logic. Okay. Oh, Aka has a brilliant question. He says, how do I make the computer be more difficult? Because right now it's a rather stupid opponent. It doesn't really know how to win. That's why computer programmers get paid a lot of money. Right inside that question is why programmers are valuable. How would you get the computer to know the right patterns and approaches to try to actually win, instead of randomly dropping an O somewhere on the board? There's no short answer to that, Aka. I'm sorry. That's the subject of a whole entire class on how would you build it to have the logic on how to win. But it's a brilliant question. Obviously, it can be done. We've all played games where the opponent is really intelligent, and sometimes they have difficulty settings, easy, medium, hard. How do you program that? Well, if you like that, go to learn how to code. go to school, join a boot camp, and you'll be able to figure all that stuff out, and it's so much fun. All right, that was a great question. All right, let's go back here. Go back down. Q&A is right here. I love that question. You all ask great questions tonight. That makes my day. All right, so let me go over briefly who and what we are and how we help people break into tech. Okay, we have 12 different coding boot camps. These are fully online boot camps. They cover, as you can see, a wide range of technology subjects: artificial intelligence, which is how you would make the computer the computer difficulty higher. Okay, artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. In fact, we have more certification programs than any other coding boot camp on earth. But it's how these programs are delivered that I think is pretty awesome. They're self-paced, so you never get left behind. They're instructor supported. They're flexible. You set your own study schedule and you can enroll any day of the year. The content is really well-rounded and really in-depth. They're really affordable. We talked about that before. And all the programs include job placement training and job placement assistance. So you can, actually succeed in getting hired, right? Most importantly, though, these programs are designed for absolute beginners. No technology knowledge or experience is required. So you don't have to be a nerd to get through our programs. And who are these programs for? Anyone looking for a better career. Technology is a great industry to work in. There's remote work opportunities. It allows for great work-life balance. It pays well. We'll talk about that. We consistently land on every major best coding bootcamp list. In fact, in January, maybe early February, Newsweek released its annual list of the top 31 boot camps in the world, and we were on that list. And considering there's hundreds or thousands of boot camps around the planet, we're very proud of that. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars, and those ratings come from our students and our graduates, and they would be in the best position to know. Now, I briefly mentioned a couple of things here, but why would you want to consider working in tech? I want to elaborate on it a little bit, okay? One, technology has really great work-life balance, and remote worker opportunities are really available. You're not going to be in some 70 or 80-hour grind of a job when you're working in tech, which is nice, okay? Also, it's a really creative industry. You can solve really cool, fun problems, you work with great people, and you can take a lot of pride in your work. And it's a stable industry that pays really well. And if you work really hard at it and keep learning, you get regular increases in pay. I just want to stress this. Yeah, it can be a challenge to get into tech. We try to make it easy, but it's worth it. Technology workers get paid really good money for a reason. They do work that other people don't know how to do, or they really don't want to learn how to do. And so you get paid really well. That said, there are some barriers to entry to doing a boot camp, and we acknowledge that. One of them is money. A boot camp tuition can cost thousands of dollars. That said, at the Tech Academy, we have multiple financing options, including a huge upfront discount, or if you need to pay monthly, we have financing programs for people with whatever financial situation you have. Another barrier to entry is time, and this is because there is a lot of material to get through in a short amount of time. Some boot camps try to solve this by making you train as a cohort, as a group. Everybody starts on the same day and goes through the material at the same pace. I can't stand that method of learning myself because sometimes I learn really fast on some subjects. Other subjects, I need to grind on it a little more. Our programs are self-paced. Part-time study is allowed, which means you can study concurrently to holding a job or going to school, okay? And finally, one of the barriers to getting through a boot camp is that you do need to have some technical interest or ability. Well, y'all took a Friday night and did a free coding class. There's probably some interest there. It's the ability point I want to talk about. You may have, at some point, when you're looking into tech, felt like maybe the education materials are too hard. Like maybe you're not smart enough to learn it or whatever. I assure you that's not true. The challenge is some educators assume knowledge on the part of the student. They can't remember what it was like when they were new to the subject, so they make training materials that assume you already know things. We don't do that. With our programs, you don't have to be a nerd. You can get through it, okay? And again, you don't have to have any technology background to enroll. With all that said, I just want to ask a couple of questions. Are you perhaps working a dead-end job, or a job that when you look forward into the future, the income ceiling of what's possible, even for really strong performers, is not where you want to be? Like maybe you're making $30,000 or $40,000 a year, and you look at people who've been in your industry for 10 or 15 years, and they're only making $70,000 a year, and you're like, that's just not going to work for me. Or maybe you're fully unemployed, or maybe you want to work from home, or you want more time with your loved ones, right? The question is it time for a career change? Well, the Tech Academy is the solution. We are career change experts. This is what we've done for 11 years, right? That orange bridge you see, we chose that logo on purpose because we're trying to provide a route into tech for everyone. And it works. We've got over a decade of experience helping people break into tech. Most Tech Academy graduates make $30 an hour in their first job. We've got well over 1,000 graduates working in tech at everywhere from small businesses, medium businesses, huge companies like Nike or Uber or Epic Games or Facebook or Disney. We have graduates everywhere. So as a reminder, we offer open enrollment. You can start anytime. That said, if you start in March, you get some pretty cool things. For students who enroll this month, first of all, you'll get a 50% off tuition discount if you can pay up front. It's a massive discount for an upfront payment. Also, if you pay up front and you need a laptop to do your studies, we can send you a refurbished laptop to keep. But that's only for students in America. Sorry. Also, if you sign up this month, you get no sales tax. We'll pay the sales tax for you no matter where you live. And we'll ship you your own copies of some of our best coding books, including the Intro to Coding book for your language, the Computers and Technology Simplified book, which removes all mystery from computers and technology, and our Tech Basics Dictionary with awesome definitions, simple, clear, easy to understand for the thousands of terms you encounter when you work in technology. You get your own copy of that. Also, if you enroll in March, you get your own physical copy of our career planning guide. This is your roadmap for the first 3 years of your career once you break into tech. What do you do? What do you need to set up for the first 6 months, first 18 months, first 36 months? How do you navigate that first part of your career and set yourself up with a really solid foundation? We put so much work into this guide because I want people to have a long-term stable career. And we wrote down how to do that. You get your own copy of that. Also, if you enroll in March, you get 90 days of free access to what's called the Tech Academy Accelerator. Aka will give you links to everything at the end here, okay? You get 90 days of free access to what's called the Accelerator. This is our subscription offering, which gives you a few things. One, access to over 100 free educational videos that aren't anywhere else, and access to access to what are called the Accelerator workshops. These are phenomenal. I deliver these every single week. And in the workshops, they're a lot different than one of the free classes. They're open voice, open camera, open chat, and we get our hands dirty and we actually build things, break things, dive into super complex concepts. Anything that I can impart to you to advance your career, we'll talk about. And I teach the subjects that the students want in that all the time. It's a lot of fun, okay? And you get 3 months of free access to that. And finally, this is huge. If you enroll in March, you get unlimited job placement assistance until you land your first job. For as long as it takes, you can work with our job placement specialists until you get hired, which is really, really cool. So, again, stick around for your free gift. It's coming here in a moment. If this is interesting to you at all, if you're at all curious about what we do, how we do it, whether or not these programs might work for you, go to this link that Gracie just dropped into chat. You fill out a simple form, and then you get, after that form, a series of steps all about the Tech Academy. There's videos and articles, and we cover what each boot camp covers in detail, what order the classes are in, why they're in that order, how you work with, how you interact with the instructors, how do your assignments get graded and looked at. Like, everything about the program is laid out in explicit detail so you can make an informed decision. So go ahead and I'm going to take a sip of water because I need one. And if you're at all interested, grab that link and fill out that form. All right. I want to talk about a referral program real quick. Since our graduates love us, referrals have been a source of enrollments for a long time, right? One of our top sources. And so a long time ago, we put in place a commission program where if you refer someone to our school and they end up signing up, we'll cut you a check for 5% of their tuition. And that's available to anyone, not just students and graduates. So in a moment, we're going to give you an email address you can use to get your free gift. And when you send in for that gift, you can also let us know about people that you think we should be talking to. We keep track of that. If they end up enrolling in the school, we will send you a check for 5% of their tuition. I mentioned books. Here they are briefly. We have 3 Learn Coding Basics in Hours books, right? We have a coding book for kids and young adults, the Technology Basics Dictionary, the Project Management Handbook, and You Are Not Stupid, Computers and Technology Simplified. This is an unbelievable book. I wish I'd had it when I was a kid. I think every adult should read it. It took us a year and a half to write that book. So here's your free gift. It is our Introduction to Python book. This Learn Coding Basics in Hours with Python book is phenomenal. First of all, it covers those 5 fundamental elements of all computer programs in even more detail, so you can learn more about it. And then it leads you through all of the fundamentals of the Python programming language. This is like I think the 2nd edition of it. It's very good, and we'll send you a free copy to your house if you want one. All you have to do is email in. Gracie just dropped the email address to use, books@learncodinganywhere.com. Send us an email saying, I was in the free class. Erik said we could have a free Python book. Please send it to me. Here's my mailing address. But you have to include your mailing address. Every once in a while, we get people that forget to do that, and we can't send them the book. Okay? So if you want your free copy, go ahead and send us an email right now asking for the Python book. And you can drop in any other questions you have for us, or you can drop in referrals all in that email. David, if you need to reach me or anything, just use that books@learncodinganywhere.com and just say, hey, I've got a further question for Erik. They'll pass that on to me. Awesome. Thanks so much. And by the way, David's question was about generative AI a little bit. If any of you are interested in generative AI, I highly encourage you to join that Tech Academy Accelerator, because we go into a lot of AI stuff in that, because it's an area of great interest and expertise for me. So I teach a lot about AI. In fact, Gracie, can you drop the link for people to get that 7-day free trial to the accelerator? Can you drop that into the chat? I know it might take you a minute to look for it. Emily, we don't need your email address. We need you to send us an email at the books@learncodinganywhere.com address. Oh, David, that's really cool. Yeah, I did some work. David says his book is on generative AI for game design. I did some work with Sony on some of their advanced AI stuff they're working on for games. It's a real exciting area, working on AI in games. All right, we mentioned links. First of all, this recording is going to be available here as well. But if you go to the Linktree service that we have in here, Gracie's going to drop our Linktree in here. This has all of the Tech Academy links in one location. There it is. Gracie dropped it in, right? You'll find links to our YouTube video playlist, including, within about a day, this recording. You'll have links to our books and our dictionary, links to upcoming meetups. If you want to sign up for another class, you'll find all the links there. All of our social media accounts, right? You'll find all that at the Linktree. And that brings us to the end. Y'all have been phenomenal. I really want to tell you how much I appreciate, especially all the questions you had while we were teaching this. They were very, very insightful, and made me think. It's awesome. Love that. Please join us for more free classes. And seriously, if there's any chance that what we do might help you or a friend, go fill out that form. Find out more about the Tech Academy. We're really good at what we do. And we really, really care about helping people break into tech. It's been a passion of mine for a very, very long time. I hope you all enjoyed this. I'm going to stop sharing and be able to have you see my silly face again. Oh, and I'm going to share my my nerdy t-shirt. It says, third to the last Jedi, give or take a few. That's my nerdy shirt for the day. I've got about 50 or 60 stupid nerdy shirts. Not a shock, I'm sure. All right, I'm going to watch chat here in case there's anything else that comes in at the end. Hey, David, do you have a link to your book? Or is it not done yet? Okay. Man, let me know. I would love that. Hold on a second. All right, David, I just shot you my email. When you're done with that, let me know. I'd love to check it out. Yeah, I love that, Aka. Star Wars is it's my jam. All right, thanks all. Have a great evening. I'm gonna go drink some more water and recover. Appreciate it. Thanks all. Thank you, Jenny. This is a great question. Bye.